Hello everyone, welcome back to Homeport. My name is Louis Potter. I'm going to be introducing the next speakers for the demonstrations. This is the last demonstration of the day. The demo will be done by UDVeo and then Falke. Just a brief introduction to them. So together with its partners, the Helmut Schmidt University performs cutting-edge research in the field of UAS traffic management and counter-UAS systems. Today, UDVeo and Falke present their project results for the first time jointly to a wider audience, actually for the second time. They will show how drone traffic can be managed safely and efficiently on the basis of a European U-space regulation, and how a highly automated counter-UAS system can enforce security in urban airspaces. Before we go to that, we've got Dronig and Christoph will be giving us a brief introduction into their system that is enabling the safe operations during the demos and during this week. So I'll hand over to Christoph now, who could talk us through that.
Yeah, thank you very much, Louis. A very warm welcome today and a very good afternoon from my side to every one of you who's made it today to the Homeport area in order to view the live demonstrations taking part today. We're very happy to be here today. As Louis said, my name is Christoph Stolle and I'm with DFS, Deutsche Flugsicherung, so that's the German air navigation service provider. And I'm there in the Department of Corporate Strategy and Organization. So I mostly work on subjects that have relations to digitalization and innovation. And of course, that includes the unmanned air traffic as well. And I'm very happy that today in my capacity as the DFS project manager for the recently set up U-Space sandbox here in Hamburg, that I have the opportunity to briefly talk to you about our UTM system. So UTM, that's the Unmanned Aircraft System Traffic Management. And our traffic management system is the first in Germany that's fully operational and commercially ready and used. And together with this system and the European concept for U-Space, we will enable the safe drone flights in urban areas such as the Port of Hamburg in the future. So we make sure that the drone traffic can be managed and that it is coordinated with manned air traffic. And yeah, we start with that here today. But before I want to talk to you about what it actually is that we're doing, I would like to draw your attention not to the sky first, but let's stay right here on the ground just for a minute. So let's look at the roads, to be more precise, and the streets, because we have a large variety of participants or users of the roads and the streets. We have cars, buses, motorcycles, bicycles, we have e-scooters, and we have pedestrians that are all using the streets. And there's a set of rules in place in order to safely manage all that traffic. For example, we have traffic lights, we have zebra crossings, we have fast lanes, we have bus lanes, etc. And they are all used to manage that traffic. And the situation in the air is actually quite similar, only that the set of rules up there is not immediately apparent for everyone. When we look up, we tend to first see the free, open, unlimited sky. But of course, up there, there's also a set of rules in place in order to make sure that the air traffic is managed in a safe manner. And this management, traffic management actually, of manned air traffic, that's our business. And we've been successfully doing that for decades now. So we're good at that. But now, with the entrance of this new airspace user, the unmanned vehicles, this traffic management environment faces a new era. Because now we have, aside from the manned traffic, we have the unmanned vehicles. And these unmanned vehicles, they have a completely different set of capabilities and needs regarding their operations. And they want to use the same airspace as the manned vehicles. So that creates the necessity to amend the existing rules. So we need to bring these two worlds together and enable them to operate in an integrated way to ensure safety for all parties that are involved. Yeah, and we want to facilitate this integration. And therefore, the DFS, together with Deutsche Telekom, has founded a drone-specialized joint venture called Dronic in the year 2019. And our joint task is to safely and fairly integrate the unmanned vehicles into the airspace. And you're probably asking yourself now, well, how do you do that? And the answer to that, or one major aspect of that, is as simple as it is important: visibility. So visibility is paramount in order to safely operate all kinds of drones operations. Because one thing that both traffic systems, the one on the ground and the one up in the air, have in common is, in order to comply to the set of rules, of course you need to know the rules, but you also need to be aware of all the participants that are using this traffic system around you. And well, in order to make this visibility possible, we need to find a way to make everyone and everything visible. And that is a new challenge to us, because usually the unmanned vehicles are just too small to be detected by the traditional radar stations. And also they're usually too small to be seen from the cockpit of a manned aircraft. And if we put ourselves in the shoes now of the remote drone pilots, they don't even have a cockpit that they can sit in and look out of and see and avoid other traffic. So we conclude from that it's essential to make everyone visible electronically. And this is especially important when we talk about operations that take place beyond the visual line of sight of the pilot. And this also holds true regardless of any particular use case. So maybe agriculture, energy, the healthcare sector, logistics, or the transport sector. We need to make sure, and we want to make sure, that everyone can fly safely. So for that reason, our UTM system that we have developed is supporting authorities, it's supporting drone operators, and it's supporting drone pilots through all phases of the flight. So that's pre-flight, in-flight, and post-flight, with functionalities such as flight planning, flight authorization, we have a conformance monitoring, we have a traffic alert, and in the post-flight section, we have a documentation and an incident management system in case there have been any incidents during the flight. So how do we actually create this visibility in a technical sense? Well, we employ parts of the German air traffic control system and also the mobile network of Deutsche Telekom. So the traffic data of all manned air traffic is coming directly from the system of DFS, and all other traffic, especially the unmanned vehicles, they are collected by special UAS hardware that's developed by Dronic. So there are many ways to incorporate the traffic data of the unmanned vehicles into our UTM system, but the way that we're showing today is via the mobile network, so 4G, respectively the LTE technology. And that's really quite straightforward. You have two options here. Either you have a drone that's already LTE ready, and you just use our ICD and hook up to our API and send your position data directly into our system. Or, second option, you use one of the Dronic hook-on devices, like this one here, You can think of it as a flying smartphone. So it sends its position, or the position of the drone rather, directly via the mobile network into the UTM system. But it also, in addition to that, collects all the traffic in its vicinity and forwards the traffic of other airspace users as some kind of relay station to the UTM system as well. So you can think of it also as a flying eye. And in addition to that even, it directly transmits its position into the avionics system of a cockpit of the manned aircraft. So if you put all that together, you end up with a situational display for the remote drone pilot that gives him the complete situational awareness of what's going on in the air. And that enables him to perform his flights in a safe manner, and that even if the operations take place beyond the visual line of sight. And what that actually looks like, you can experience in just a few minutes. You can do this by just taking out your smartphone and scanning that QR code that's shown on the flyers that are laid out throughout the area here. And if you do that, you will be directly forwarded to our web display. This is a very basic web display, so it just shows you what I described situational awareness-wise. It doesn't include all the other functionalities, so it's the basic display. But if you activate that now, you can then follow the demonstrations on your smartphone as well as looking into the sky and following the drone live. And that's possible because the guys from UDVeo were so kind to attach one of our LTE transponders to their unmanned vehicle so that we can show it in the system. So thanks again for this opportunity that we can use your demonstration to demonstrate our UTM system here as well. And yeah, that's it from my side. If you would like to have any further information on our current activities, I kindly invite you to check out the websites of Dronic or DFS, or both. We also have some information monitors ready for you at the ITS. That's the booth of the Federal Ministry of Transport and Digital Infrastructure. That's in Hall B4, so if you're curious, go there, check that out. If you have some immediate questions right now, please feel free to just approach me here in this area. I'm also here with my colleague Juliane Lang. We're both happy to answer some questions if you have them right now. And yeah, that's it from me. I would like to hand over to Marius now to get the demonstration on its way. And thank you everyone for your attention. I wish you always blue skies, so we're getting there now, and safe landings.
Yeah, thanks, Christoph. Just initially a remark before we start. We're going to show a lot of software, so please make sure that you're situated somewhere that you can see either that screen over there or that one over here, and we'll try not to stand in the way too much. So, as we just learned from Dronic, drones hold enormous social and economic potential. People use them for leisure activities, for building inspections, for emergency uses like police use and firefighter use. And an important factor for all these purposes is to organize drones in a way that collisions can be avoided, obviously. They can be achieved through a common rule set that everyone is bound to, similar to road traffic. So we all know to stop at red lights, and we all know basic traffic rules. For this to be realized, the US defined regulations that are to enter into place in January 2023, and this is called the use-based regulation. This use-based regulation is to define the boundaries and outlines for how drone traffic works, and this is also the basis on what we founded our project on.
So this is where UDVeo comes into play. UDVeo stands for Urban Drone Traffic Efficiently Organized, and it's a research consortium consisting of 8 partners that combine legal, operational, and technical expertise. The project is funded by the German Federal Ministry of Transport and Digital Infrastructure, and our goal is to develop practical concepts to integrate drones into the urban airspace according to the EU regulations. And for this purpose, we are developing an overall concept in compliance with regulatory and technical requirements. We're going to take a short look at the ecosystem that we're dealing with. So what we already know is that today there is a multitude of drone operators, and they may use different solutions to plan missions and to organize flights. Today, we're going to take a look at two of them in specific, one of them being HALA Sky ICC, and the other one, Auterian Mission Control. On top of this, for different operators to coordinate their flights within a U-space airspace, EU regulations require them to use the service of a so-called USSP, which is a U-space service provider. The USSP offers a variety of services, specifically services that ensure that with growing traffic, conflicts are avoided. And in our project, we developed a prototypical USSP control center aimed to seamlessly integrate existing operator solutions through a common API. And this means that an operator does not need to use any additional software in order to interact with us. And the EU regulations foresee that within a U-space, several USSPs can offer their services, for example, Dronic, and also UDVeo, and this means that the services are to be competitively organized. The USSPs, of course, have to coordinate with each other to be able to provide their services, and this can be achieved through a so-called SCISP, which is a single common information service provider. And with the help of this entity, approved flights and other relevant data from different actors can be distributed within the network. And if we now take a look at those other actors, that could, for example, be manned aviation that provides traffic data of airplanes, or on the other hand, authorities that, for example, establish no-fly zones in case of emergencies, for example, if a World War II bomb was found somewhere in the city. Today, we want to present you a practical demonstration of how drone missions can be planned with both HALA Sky as well as Auterian Mission Control, and authorized with the prototypical USSP control center.
Okay, let's show the perspective of a drone operator. For this, we were showing the HALA Sky Integrated Control Center, which is a web-based application to manage a lot of drones in a fleet of drones, especially dedicated to BVLOS applications. Before a drone can take off, according to EU regulations, there has to be an early check for potential conflicts. For this purpose, a drone operator has to submit a digital flight request to the USSP. For our presentation, we've already prepared a few missions just to make things easier here. As said, we have integrated two existing drone operator solutions into UDVeo, again over a common API, and are now going to show the flight authorization workflow with these tools. The mission that we want to submit today is an inspection mission. So we're going to fly over the canal over there and going through some basic measurements. And then return to the takeoff spot. Through the disposition view, the mission is assigned to a specific drone, a specific pilot, and a specific window in time. And this is all automatically transmitted through the USSP, and we're waiting for confirmation. In addition to this, we've prepared a parallel mission in Auterian Mission Control. In this case, we want to draw a map of the parking deck over here. So this is our mapping area. And again, we've created a flight plan, and with a simple click, we are submitting that flight plan to the USSP for permission.
So now, if I put myself in the role of a USSP, we can switch over to the USSP application, and we can now see that we have received the two requests. They are on the very bottom. And now we're going to look at the HALA Sky mission in detail. Now we can see on the right-hand side, there's metadata of the flight, for example, a person we can talk to in case of an emergency, as well as the estimated duration and the length of the mission. As an operator, I can check for conflicts with previously authorized flights, but also special areas like, for example, helicopter landing spots or no-fly zones. This information is what we get from the SCISP. And in this case, we can see on the map as well as on the timeline at the bottom that there are no conflicts, so we can authorize this flight. So taking a look at the other mission that we saw from Auterian Mission Control, we can see in the timeline at the bottom that there is a temporal conflict because both flights are taking place at the same time. But looking at the map, we see that there is no overlap. And because of this, we can authorize this flight as well. So at this point, we need to look at something called an activation. Before a flight can actually take place, the EU regulations require a dedicated flight activation, and this enables the consideration of sudden events, for example, a police operation. And we're now going to show how a flight activation is processed, and for this we are switching over to the control center of a drone operator, and in this case, HALA Sky ICC.
Okay, so let's put ourselves in the boots of a drone technician who's checking the hardware. In the HALA ICC, a dedicated hardware check is mandatory. So the drone technician on field has to go through a certain pre-flight check, which is to make sure that the drone is working as intended. So we're going through this point by point and recording that the drone is working fine. As soon as the drone has been completely audited, an activation request is automatically sent to the USSP just after finishing this pre-flight check.
And now, if you switch back to the USSP, in our USSP control center, in the activation menu, we can see a real-time visualization of all current flights from both manned and unmanned aviation. And here on the right-hand side, we can also see activation requests for flight authorizations that we have previously granted. And since there are no current danger alarm messages or any other obstacles that would keep us from executing this flight, we can now grant the activation.
Okay, back to the HALA ICC. In our HALA ICC, we can now see die Flugfreigabe wurde erteilt. Our activation has been granted. So we are able to activate that mission. In parallel, we can see that the Auterian mission also has already been granted and is being executed in air. And we are now going to start the HALA Sky mission as well, which is to take off and then do its mission. So as we can see, the drone is taking off, and from the drone operator's perspective, we can follow in the guide stand as well as in the air that the drone is doing its path as intended. Don't be irritated by that black drone, that's a simulation drone that we've just put there for demonstration purposes. So as you can see now, the drone is commencing its mission, and we are following this right here in the operator's guide stand.
So if we switch back to the USSP control center, on the map we can follow the drone flight. We see track and information for all current flights, and this data can be displayed in the USSP through a multitude of technologies. In this case, we're using NXP's 802.11p Wi-Fi technology because of its low latency as well as its mesh network functionality. And this requires the usage of a D2X ground station that you can see on the other side. It's a black box behind the fence. And what we've seen so far is the standard workflow for mission planning, flight authorization, activation, and flight execution. And if there were no further unforeseen events taking place, the flights would just end regularly as planned. However, to show that our approach can also deal with unforeseen events, let's look at what happens when things do not go as planned. In this case, we are putting ourselves in the role of the police that just arrived at an accident location on the other side of the canal, and we are awaiting the arrival of a rescue helicopter, and all nearby drones have to leave the airspace for it to safely land. And now, if we were the police, we would look at this web tool for entering information that is distributed via the SCISP. And in this case, we want to establish a no-fly zone for the helicopter to land in. And such a no-fly zone has to have a name as well as a description, a starting date, a type, and a geographical area that you can see on the map. So as soon as the police establishes the no-fly zone, the information is automatically distributed to all USSPs through the SCISP and now can be seen in the USSP flight monitoring view.
In our HALA ICC, we can now see that as well, and the no-fly zone has been established by the police, leads to a conflict with our mission. The drone would now fly into a no-fly zone, which makes no sense because we said we wanted to take certain measurements, which means a conflict cannot be avoided. So since our flight consists of specific spots, we have to cancel that flight. We're going to prompt the drone to return to home with a simple click of a button. And if you carefully look at the sky, the drone will now stop its mission and return to its home position. Since the drone is coming back now, it's not flying into the no-fly zone, we have resolved the conflict and are good to continue.
If we switch back to the USSP, as I've said previously, you can see all current track and information of all drones in the sky. And we can see that the drone from Auterion is not conflicting with either the no-fly zone or the changed route of the other drone. And since it's not impacted at all, it can just continue flying its mission as it was planned. Finally, we will probably see in a couple of seconds that the helicopter is going to arrive at the scene. This data is also displayed in the USSP. And in the meantime, we can also see that the other drones are trying to land. So in this demonstration, we wanted to show you how drone flights can be requested, authorized, and surveyed. And in addition, we showed a drone having an unforeseen conflict mid-flight and solved it by landing the drone before it finishes its mission. If you want to personally try out our prototypical USSP control center and the HALA Sky ICC, you're very welcome to visit us in Hall B4. And there we have many more exciting things to show you. One of the highlights is certainly that you can experience flight planning in augmented reality for yourself using a HoloLens. And for more information and contact details, we also invite you to scan the displayed QR code. Does anyone have any questions? So to conclude, we have to emphasize that the entire scenario dealt with drones that were known to the USSP. They communicated with the USSP, they followed the commands they received from their respective control centers and the ground stations, so in short, they were cooperative. As we know from the news, there are also non-cooperative drones, and the handling of such drones is presented by our colleagues from the Falke project.
Thank you.
So, ladies and gentlemen, I hope you will not leave immediately, because I have to tell you that we do not make a live demo. And the reason is that we typically fly at airports where we have a space which is much larger than the space we have here. And therefore we had to scale down the complete system, and it was not possible for us to scale the system down and to guarantee for the safety of the people. Of course, if you stand here and you look there to the parking place, it's hardly to understand that there might be a difficulty. Hamburg was very flexible in handling the things. That was not the problem. But at the final end, we need some signs under some documents, and we couldn't get them. So, and that at the final end, we can't make a live demo. Instead, I can show you some videos, and I'm very sorry for that. And I make it short, and I hope you can enjoy the 2 videos where you see how it operates at the final end. So the project Falke is, if you want to interpret a deeper mention into this acronym, stands for capability of intercepting small unmanned aircraft entering restricted airspaces by civil means. And the point here is that civil means we do not protect an army camp. We want to protect airports, civil airports, and therefore the threat scenarios are totally different, and also the means you can take to pick an unwanted UAS from the sky. And as you see, there are quite many partners included in the project. All these institutions which are part of the value chain at the airport are also included in this project. I jump over some slides. Here you see the main building blocks of the complete system. Of course, you need some sensors at the front end to detect if there is an unauthorized drone. The sensor systems are coming from Hensoldt. Then there is much of communications, and the so-called incident management systems is developed by Frequentis. And on the effector side, we rely on a already existing platform from Euro Avionics, which is now with Hensoldt Avionics. And of course, the stakeholders are the Bundespolizei, and which is, according to the paragraph 4 of the Federal Police Act, responsible to protect air traffic security against attacks. And this institution at the end, final end, will be also responsible to get the things fixed and the system bought. And of course, the other institution already responsible for safe, orderly and fluid air traffic is the DFS. So here you see the Hamburg airport embedded in the inner city. And you can imagine that the distance from a small UAS to the fence of the airport is very narrow, and it can happen that such a small UAS can cross the fence of the airport, which is not a very good situation. We all are sure that that small or bigger UAS have a great economic potential and a high social benefit, but that there are places where they shouldn't fly, at least uncontrolled. Here to the left you see the typical vehicle-mounted sensor systems we typically deal with in our field trials. And to the right you have the Counter-UAS, which has a mean takeoff weight of 21 kilograms and can carry a payload of 8 kilometers. the maximum speed is about 120 kilometers per hour. So, and here, when you look at on the sensor side, you also see the problem. When you want to describe the performance of a radar system, you do that typically with the means of a radar cross-section. And if you look here, the detection range for a small micro UAS is about, let's say, 10 times 10 centimeters. And you can, with this vehicle-mounted radar, you can detect a small UAS at a distance of 2.3 kilometers. And the radar cross-section, this is the point here, is about the size of a bigger bird. Therefore, you have to here at this place to distinguish between a bird and a small UAS. This is typically done with the help of electro-optic infrared sensors and RF detection rangefinders. And to see the performance here, if such a radar would have been equipped in a car, for example, for autonomous driving, you can see a small vehicle in the distance of 10 kilometers. So it has also this relatively small radar system has a quite good performance. So this is the normal operation of airport. You see the runways, the perimeter in orange, the control zone in yellow. The planes are coming in and are going out, and of course you also see them on the radar. But of course these are no drones. Therefore you need the information, or unauthorized drones. Therefore you need the information from the air traffic management system, and the data have to be fed into the incident management system. And then there is maybe one UAS showing up, but at this point that's not the big problem. It's already seen by the sensor system, but in the future we want to cultivate this technology, and then many UAS are showing up. And some of them are landing and starting even at the airport. Therefore, you also need the information of the UTM system, of an unmanned aircraft system, traffic management system. And of course, there is a small risk that things are not doing so well as expected. Therefore, we do not want to take this, we call it dogfight, in situations where it could be dangerous in the vicinity of terminals, parking aircrafts, or fuel depots, for example, which means we have to make dynamically virtual geofences, and we have also to include building maps. And then the red UAS is crossing the fence, and then an incident is triggered, which is then fed into a cloud system. And this is the big difference now, that we do not believe anymore on telephone chains. All the institutions have the same informations and have the same view, and can get the same data. So all of the institutions are informed: law enforcement, ANSP, the airlines, and airport safety and security. And here you have the different views on the different workstations. So, and now I skip some slides and I come to here first to the simulation. We built a complete simulation environment for our Counter-UAS system. To the left you have a satellite map view of our test field, and our Counter-UAS system is equipped with different sensors. In total, here we have 3 different sensors: a normal RGB camera, stereo camera, and a LiDAR. And now we simulate such a dogfight. I started here to the yes, now it starts. To the right you see the blinking rings, blue and red. That's a hypothetical point where the unwanted, the unauthorized UAS should show up. This point is as indicated by the radar system. Then we fly to the so-called rendezvous point. And when we are close, about 20 to 50 meters to the unauthorized drone, then we have the unauthorized drone in our own sensor systems. And then now it comes to this point, we follow the unauthorized UAS automatically, and the next phase is then someone is giving the order, catch it. That's coming now, and we shoot. So that is the pure simulation, and you will see that the simulation is close to reality. Here is the video of the field trials we did. It's starting soon. No, you see the north loop of the runway here at the airport Hamburg. The Counter-UAS is prepared by the Counter-UAS team. The communication between ground station and Counter-UAS is on, and now you see the complete automated dogfight. The Counter-UAS is following the unauthorized smaller drone automatically, and then in the appropriate position the net is shooted, and now you see it from different visions. Now it's caught and it's hanging down the line. Here we have only one net thrower. In total we have 2. The other one is equipped with a camera to document what you see here. Shoot. And hanging along. And now you see there's it's quite good agreement with the simulation. This is the view from the sensors, from the Counter-UAS. Shoot. And catch. And again. Yeah, and when at Fineland, when we caught the unauthorized drone, we bring it to a predefined place, and then with the documentation at the final end has to be done. So, and the last video is the view inside from the radar system. Here to the left, you have the view from the radar system. You see 2 drones. And in the middle you have the view of the infrared detector from Hensoldt. And now when I start the video, you see that now you have 2 drones, which then will result immediately in only one view of a drone. That means the other one is catched. And you see it here in the middle that is hanging down the line. So, in principle, it operates quite well, but not in small places where the documents are not done. I'm very sorry for that. So, that's the end of my talk, and I think that's also the end of this session. Thank you very much for your attention.